Okay guys, just do reply fast. Am I audible? Good morning to all of you. Let's start today's class. Laplace transform. सब playlist में Laplace का part 3 नहीं है. Okay Bharat, we'll make sure that beta today after 2 hours we'll definitely complete the playlist. Okay, whatever the missing part there, I will check. Okay. So just do reply all of you. The voice is clear, audio video is crystal clear. Good morning Vaidehi. So in the last class we have seen about the Laplace transform ROC and we have concluded the properties of the ROC. Just confirm. Reply all of you. The voice is, I think voice clear, yes. So Bharat, we will update the Laplace transform part 3 also very soon in the playlist itself. Okay, chali. So let's start the session, bachcho. Laplace transform properties. The last class was dedicated for the right side signals. The common ROC will be right hand side to the rightmost pole. For the left side signals, the common ROC will be left hand side to the leftmost pole. All these properties we have discussed for the both sided signals. Both sided signals will be always non-causal because both sided signals are a combination of right sided and left sided signal, and whenever any left sided signal will come into picture, it will make the non-causal only. Yes or no guys? After that, if I talk about the next property, for both sided signals, the common ROC must contain a rectangular strip in the S-plane. If for the both sided signal, the common ROC is not containing the rectangular strip, it means we have only one choice, that is no common ROC. So in the both sided signals case only, no common ROC case is possible, and no Laplace transform is only possible for the two sided signals or both sided signal. For stability, ROC must include imaginary axis. For causality, ROC must be right hand side to the rightmost pole. So these all are we have discussed already till the last classes. Now guys, I am asking this question to you. Tell me what is the Laplace transform of u minus t and what is its ROC? What is the Laplace transform of u minus t and what is its ROC? Come on. All of you guys do reply fast. All of you beta just let me know whether he Bharat. What is u minus t Laplace transform and ROC? What is its Laplace transform and what is its ROC? Come on, you need to tell me. What is the Laplace transform and what is the ROC? You should tell me. U minus t Laplace transform. So because we know the standard form e to the power plus at u of minus t, its Laplace transform is nothing but 1 upon minus s plus a, and ROC sigma is less than, because of u minus t, ROC is less than kiske less? Multiple of t, so here is sigma less than a. In this expression only, if I will put a equal to 0, then I will get u of minus t, Laplace transform is nothing but 1 upon minus s, and sigma ROC is less than 0. So this is nothing but u minus t Laplace transform. I hope this part is clear beta. Whether he do reply parallelly, whether he is there any lag. I hope whether you have already completed the last lecture. Last lecture I hope you have already completed. Yes. So last lecture already available in the our YouTube channel guys. So e to the power, here we have a u minus t. So u minus t Laplace transform. So u minus t Laplace transform 1 upon minus s and sigma less than 0. Sigma less than 0. सर कल के लेक्चर के बारे में पता ही नहीं चला था प्लेलिस्ट में. ओके बेटा वैदेही. Yes, we'll make sure that playlist will be updated. Okay beta, playlist will be updated. We will make sure that. Okay. Sorry, from the technical team side, they have missed to update the live lecture link in the playlist. So what I suggest beta Vaidehi and all, you please go through the YouTube channel also. In the YouTube channel, upcoming live stream, upcoming live lecture na, just make a reminder beta. Just make a reminder bachcho, just make a reminder. Okay. Suppose that tomorrow also we have a session. So today only it will be shown in the upcoming live stream. In the upcoming live stream, when you will go there, you just click on the set reminder, so that however we'll make sure that lecture will be available in the playlist as well. Okay, chali. So u minus t Laplace transform 1 upon minus s. Now bachcho, tell me what is the Laplace transform of 1? Can you put, anybody tell me what is the Laplace transform of 1 now, and what is its ROC? Come on, I'm asking a simple question. What is the Laplace transform of 1 and what is its ROC? Come on, Bharat. I will watch the lecture right after this video. Okay, no problem, Vedai. Just tell me, bachcho, what is the Laplace transform of 1? What is the Laplace transform of 1, guys? What is the Laplace transform of 1? I am expecting answer from you all. Whether he can tell me what is the Laplace transform of 1? Chali. Come on, guys, tell me what is the Laplace transform of 1? So, student, if I talk about, so generally students are replying 1 Laplace transform is 1 by s. 1 Laplace transform is 1 by s. But what is happening, bachcho? 1 Laplace transform is 1 by s. It can be true in the control system case, because in the control system, if we are writing 1, it is by default working as a ut, because in the control system we all talk about 0 plus region, we all talk about the causal signals. So, in the control system, if I will talk about 1 Laplace transform, it is by default treated as a ut and Laplace transform 1 by s. But in the signal sense system, when anybody asks about the 1 Laplace transform, do you know the property, guys? Ut plus u minus t is actually equal to 1 in the signal system properties, we know that. And if I will find the Laplace transform of ut plus u minus t, first of all I have to check the ROC. First of all I have to check the ROC. If my xt signal is 1, then 1 is equal to ut plus u minus t, and ut ROC is what, guys? Very good, Vedahi. Ut ROC is sigma greater than 0 and u minus t ROC is sigma less than 0. So, there is no common ROC, guys. So, there is no common ROC, and if there is no common ROC, there is no Laplace transform. There is no Laplace transform. If no common ROC, then no Laplace transform. I hope this is clear to you. So, if anybody will ask about this, then you should write no Laplace transform. Laplace transform is not possible because no common ROC. Because of no common ROC. Shabash. So, 1 Laplace transform is not possible. If I talk about the ut Laplace transform, of course possible 1 by s. U minus t Laplace transform 1 upon minus s, sigma less than 0. Ut ROC sigma greater than 0. But 1 does not have a common ROC. And just because does not have common ROC, we don't have any Laplace transform. Chali. So, next go for the next signal, basic signals Laplace transform. Now, I am asking a Laplace transform of signum function of t. How many of you know the Fourier transform of signum function of t? If I will ask about the signum function of t Fourier transform, then you must reply कि sir signum function of t Fourier transform twice upon j omega, and 1 upon or j upon pi t Fourier transform is signum function of omega. Or you can say that signum function of omega inverse Fourier transform is j upon pi t. Haya na bachon, 1 upon pi t Fourier transform is minus j signum function of omega, and that 1 upon pi t I have used in the Hilbert transform transfer function. I hope you remember. Now this time I am asking ki what is the Fourier transform of signum function of omega? What is the Fourier transform of signum function of omega? What is the Fourier transform of signum function of omega? 2 by s. Okay. Okay, beta. So, what I am writing here, bachcho, can I write signum function of t as a? Can I write signum function of t as a u of t minus u of minus t? Bolo beta, हाँ या ना? Yes or no beta? Yes, because we know that, so this is the relation between the signum function of t and ut. The signum function of t curve is nothing but a odd signal. Signum function of t curve is nothing but a odd signal, just like this. This is +1, this is -1, and this is nothing but signum function of t with respect to t. Now here you should tell me, प्यारे बच्चों, signum function of t ut minus 2. Before finding this, we should just check the ROC. So what is the ROC of this? ROC of ut sigma greater than 0, and ROC of u minus t again sigma less than 0. So sigma greater than 0, sigma less than 0, there is no common ROC. And if there is no common ROC, there is no common ROC. So if there is no common ROC, then no Laplace transform. No Laplace transform. I hope these two part is crystal clear to you. All of you guys just do reply fast. Shall we go for next? Shall we go for next? So if anybody will ask about the signum function of t Fourier transform, it's twice upon j omega. But signum function of t Laplace transform, it's not possible, or it's not converges, because no common ROC, so no Laplace transform. So here is also no Laplace transform. All of you guys just can't determine. Shall we go for next, bachcho? No problem, Vedai, no problem. From every concept we are having learning. So you should make sure that whatever mistake you have did, it will not happen in the future again. That is the best way of learning. Chali. So now I am asking a next question to you, bachcho. Can you please find out the Fourier Laplace transform of e to the power minus mod of t? Can you please find out its Laplace transform as well as ROC? Laplace transform and ROC. So find Laplace transform and ROC of this function. Find Laplace transform as well as ROC. As well as ROC also question mark. Yeah. So tell me how to start. E to the power minus a mod of t. If I will remind the Fourier transform, then e to the power minus a mod of t, Fourier transform, I hope you remember, it is twice a upon a square plus omega square. This is nothing but the Fourier transform that we have already discussed. Yes. Now student, here e to the power minus a mod of t Laplace transform. So do you know what is the curve? Sir, it is a bounded signal absolutely, and it is a even signal also, just like this, 0 to t, and this is what? E to the power minus a mod of t. Yeah. I hope this is clear to you, beta. I hope this is clear. So because it is a bounded signal, so can I write e to the power minus a mod of t is equivalent to e to the power minus plus at u of minus t. Because if I will take the negative values of time from minus infinity to 0, I can multiply with u minus t, and this time t value negative. So when negative t is coming outside, minus plus, and plus, of course, if I will take positive value of t, it will give me e to the power minus at into ut. Now you should tell me, beta, what is the Laplace transform? What is the Laplace transform of this and this? So e to the power at u minus t Laplace transform is nothing but, before finding the Laplace transform, you should check the ROC. Before finding the Laplace transform, you should check the ROC. Yes. So if I check the ROC here, ROC will give me sigma is less than what? Plus a. So one ROC says that sigma less than plus a, and one ROC says that sigma is greater than minus a. Sigma is greater than minus a. If I will make the S-plane diagram, then the ROC will be one pole is at minus a and one pole is at plus a. And this ROC is actually right hand side. Sigma is greater than minus a and sigma is less than plus a. Is this clear, beta? Yes. So this is your sigma and j omega, and this is your S plane. Is it clear, bachcho? So what you are getting? Minus a to plus a. Shall we say that, sir, here ROC containing a rectangular strip in the S plane? Shall we say like that, guys? ROC containing a rectangular strip on the S plane, and it is a both sided signals, and yes, we have a common ROC. Because we have a common ROC, we can write the Laplace transform as well. E to the power at u minus t Laplace transform is nothing but 1 upon minus s plus a and plus 1 upon s plus a. So e to the power at u minus t will be 1 upon minus s plus a, and e to the power minus at ut is nothing but 1 upon s plus a. So when you will take the LCM, bachcho, if you will take minus common, then you will get inside the bracket s minus a, and plus also you will get inside the bracket s plus a. Now bachcho, tell me, when I will take the LCM, what I will get? I will get s minus a here, and I will get s plus a here. So minus sign is here. If I will write here s plus a and plus also s minus a. So if you will simplify it, tell me what you will get. If you will simplify it, you will get here minus s minus a plus s minus a. So here is, don't you think a plus b, a minus b it is? A plus b, a minus b. So you should write s square minus a square, and s get cancel out. So the final Laplace transform will be minus ka twice a upon s square minus a square, and its common ROC is sigma is greater than, common ROC is sigma is greater than minus a to plus a. So now tell me, bachcho, this is the final expression. All of you guys, let me know whether it is stable or not, or whether it is causal or not. Tell me, just comment on the causality and stability for this. Whether he do comment on the causality as well as stability for this. Do it fast. Do comment on causality as well as stability. Very good, beta. Vedai, correct only. So if I talk about the result, if I will just write the result in a box, e to the power minus a mod of t Laplace transform is nothing but minus twice a upon s square minus a square, and ROC is both sided, sigma is greater than minus a and less than plus a. So this is a box that we need to remember for future as a standard result. This is the standard result we should keep in a box, and we should directly remember as far as competition examinations are concerned. Very good. So because ROC includes the imaginary axis, we have observed that because ROC includes imaginary axis, because ROC includes imaginary axis, so that is why it is 100% stable only. And because the ROC is both sided means it is 100% non-causal only. Because ROC containing both sided, it means both sided itself says that it is a combination of right sided and left sided will be the responsible to make it non-causal. So I hope this part is also crystal clear, beta. Shall we go for next? Whether he chaliye, shall we go for next? Chaliye bachcho. So now we will discuss the properties of ROC. We will discuss properties of ROC we have already discussed. Now we will writing properties of Laplace transform. Properties of Laplace transform. So if I talk about the properties of Laplace transform, is if x1t Laplace transform is x1s, if x2t having the Laplace transform x2s, then ax1t plus bx2t having the Laplace transform of ax1s plus bx2s, and this is nothing but the property number 1, linear property. If I talk about the first property, that is linear, then linear property says that it satisfies superposition as well as homogeneous. If I talk about the ROC, suppose that this function, first one is having the ROC R1 and second one is having the ROC R2, then here you will get the common ROC that we are actually already find out. We already find out in the last class. Common ROC is nothing but R1 intersection R2. If I talk about the example here, R1 intersection R2. What is the R1 intersection R2, sir? If I take about the example, let me take the example. If xt is a e to the power minus 3t ut and plus e to the power minus or e to the power plus 3t ut, then tell me what is the common ROC. So the actually common ROC is nothing but the intersection. It means if I will make e to the power minus 3t ut, both are ut. So ROC must be right side to the rightmost pole. So here is one pole is at minus 3, ROC its right side, and second pole is plus 3. Second pole is plus 3 and its ROC also right hand side. So if I will make the ROC curve, just like this, you should tell me where is the common ROC. You should tell me, beta, where is the common ROC. All of you guys just let me know where is the common ROC. So you say that this is the common ROC. This is nothing but R1 intersection R2 only. This is the intersection region. So we can say that the common ROC is nothing but R1 intersection R2. All of you beta just complete this part. These types of concepts we already discussed in the last class. है ना? So common ROC is nothing but greater than 3. Common ROC is nothing but greater than 3. And because of this example is causal but unstable. Causal but not stable. Causal but not stable. Why causal? Because ROC is ultimately right hand side to the rightmost pole. But why not stable? Because ultimate ROC does not include the imaginary axis. Bolo हाँ या ना? Shall we go for next, guys? Do reply fast. Yes or no, beta? Yes. So if I talk about the next property we are writing time reversal property. Time reversal property. Now what time reversal property says that? Time reversal property says that if xt has a Laplace transform of x of s, if xt has a Laplace transform of x of s, then x minus t having the Laplace transform x of minus s. If xt Laplace transform x of s and if it is having the ROC R1, then x minus s having the ROC of minus R1. How, sir? So if I take the example, e to the power minus at ut is having the Laplace transform 1 upon s plus a and ROC sigma is greater than what? ROC sigma is greater than minus a. If I will replace here t with minus t, then here s will also replace with minus s. This is the simple time reversal property. So if I will talk about e to the power, if I will replace minus t wherever is t, so it will give me e to the power plus at u minus t, and Laplace transform is what, guys? Laplace transform is nothing but 1 upon minus s plus a. Laplace transform is nothing but 1 upon minus s plus a. And what is the ROC here? If sigma is replaced with minus sigma, then here is minus sigma greater than minus a. And so because ROC is sigma, then right now, so if the ROC is R1, then it will become also minus R. Like that you can remember. However, you can just make it positive by just shifting in left side and right side, left hand side and right hand side. So sigma is less than a. So I think the property number 2, time reversal property, is also crystal clear to everybody. Just do reply fast. All of you guys just do reply fast, beta. Shall we go for next? Every student just do reply fast. Shall we go for next? Bolo bhai, bolo. Whether he till now everything is completed or not, beta? Till now everything is completed. Just let me know. Clear, sir. Chalo. So next property we are writing the property number 3rd, that is time shift property. I am writing time shifting property. So if I talk about the time shift property, guys, you can say that sir, xt, if xt is having the Laplace transform of x of s, then x of t minus ka t0, x of t minus ka t0. I hope you remember time shifting always carries same sign. So e to the power minus st naught into x of s. Similarly, if I talk about x of t plus t naught, the Laplace transform is nothing but e to the power plus st naught into x of s. So like this you guys can relate with the time shifting property. Time shifting property always carries same sign. Time shifting property always carries same sign. Because of minus sign here, this minus sign also reflect here. Because of plus sign here, plus sign also reflect here. Xt minus t naught Laplace transform e to the power minus st naught into x of s. Xt plus t naught Laplace transform is nothing but e to the power plus t naught into x of s. I hope this part is clear बच्चों. Same sign and frequency shifting opposite sign. Yes. So if you want to relate with this बच्चों, time shifting property does not affect the ROC. ROC will remain same. Its ROC is R, then its ROC is also R, because it does not affect on the pole, because time shifting of property does not affect on the pole, so ROC is same only. So you can also say that time shift property does not affect ROC. You can also make a note, time shift property does not affect ROC, or ROC does not affected by time shifting property. If you want to relate the property, guys, you just want to write the formula. Just write the Laplace transform formula, x of t into e to the power minus s t naught, e to the power minus s t dt. This is nothing but the simple Laplace transform formula. Bolo hi na. This is my simple Laplace transform formula. Bolo hi na bachcho. Yes. So if I want to write here, ki sir x of t, if I will replace here x of t minus t naught in place of xt, if I will replace x of t minus t naught e to the power minus st into dt, then what you will get in place of t? So I am putting t minus t naught is equal to lambda. So if you will differentiate both sides, you will get dt equal to d lambda, because constant differentiation is 0 only. If you will do this modification, your limit, t limit will become in lambda minus infinity to infinity. Here you can write x of lambda and e to the power minus s. Now this t will become what? This t will become, actually you should write here lambda plus t naught. Bolo hai na. And into d lambda is nothing but ds, dt is nothing but d lambda. So I am writing here dt is nothing but d lambda. So ultimately what you can write? You can write minus infinity to infinity x lambda e to the power minus s lambda d lambda, and what is outside the bracket? E to the power minus s t naught. So don't you think it is nothing but the Laplace transform? So it means it is e to the power minus s t naught into x of s. So that is why we are having e to the power minus s t naught into x of s. Do it fast, guys. Do it fast. Complete this part. I just do reply fast. The time shifting property is clear. Here we have seen how the time shifting property has coming. So because of this time shifting property, and we have also noted that time shifting property does not affect the sign. Actually, so let me take the example. If I talk about the example, guys, tell me what is the Laplace transform of u of t minus 4? What is the Laplace transform of e to the power minus 2 t minus 2 into u of t minus 2? Come on, tell me what is this Laplace transform, guys. So its Laplace ut minus 4 Laplace transform is 1 by s into e to the power minus 4s, but as far as ROC is concerned, it is still sigma greater than 0. Similarly, e to the power minus 2t ut Laplace transform is nothing but 1 upon s plus 2, and because of time shifting t minus 2, so e to the power minus 2s term also will come in the numerator, but still the ROC is nothing but sigma is greater than minus 2. Sigma is greater than minus 2. So these are the two questions. E to the power minus 2t minus 2, e to the power minus 2t minus 2, ut minus 2. The Laplace transform is nothing but this, and here is also the Laplace transform is nothing. All of you guys just do reply fast. Shall we go for next? All of you guys just do reply fast. Shall we go for next? Chaliye Vedai, do reply. So time shifting property does not affect the ROC because it does not affect the pole. Chaliye. Next student, the next property number 4, I am writing here frequency shifting property. I'm writing here frequency shifting property, okay, frequency shifting property. So if I talk about the frequency shifting property, how can you write, bachcho? If xt has a Laplace transform of x of s, if xt has a Laplace transform of x of s, and if I talk about frequency shifting property, I can write e to the power minus at into x of t. So can you please tell me what is the Laplace transform? The Laplace transform will be x of s plus a. If I talk about e to the power plus at x of t, so its Laplace transform is nothing but x of s minus a. It means frequency shifting always carry, tell me guys, frequency shifting always carry opposite sign. Frequency shifting always carry opposite sign. I hope it is clear to you. Frequency shifting always carry opposite sign. However, here I am taking the real value. It can be real plus imaginary also, or only imaginary also. Like that, I can also write e की power plus j omega 0 t into x of t. Then what is this Laplace transform? So its Laplace transform is nothing but x of, bolo bachcho, x of s plus or minus, because plus sign is here, so opposite side, minus j omega 0. Similarly, if I write e की power minus का j omega 0 t into x of t, so its Laplace transform is nothing but x of s plus j omega 0. But what is the difference between these two? Okay, these two. So if this is having the ROC R, if this is having the ROC R, then what is this having ROC? So you should write ROC is nothing but here s plus a. Frequency shifting affect the property because frequency shifting affect the pole. So sigma ROC is nothing but sigma plus whatever this value, guys, whatever this value. So here I must write minus a. Here I must write ROC is nothing but R plus whatever the t coefficient. So here I am writing plus a. So this is how the ROC. It means, guys, if I will take the example, what is the ROC here? So here ROC does not affect because here the multiple factor is the imaginary factor, and ROC is nothing but always mode of s actually, mode of s. So mode of s, it means sigma. Sigma is nothing but mode of s. Sigma is nothing but if I will write s equal to sigma plus j omega. So if I talk about the magnitude part, if I talk about the real part only, real part of s. So real part of s only will give you the ROC. So real part of s, it means sigma only. Real part of s it means sigma only. So ROC is here R only, and here is also ROC R only. Because in a ROC is always represented by real part of s, real part of s. If you are shifting with imaginary part does not affect, because in the ROC we are covering only sigma. ROC is nothing but the region of sigma. In sigma region, j term should not come. J term can't come in the sigma. Okay, so sigma is nothing but real part of s, yes. So this is how you guys can relate. I will take the example also. And if I talk about how these properties will come, then you can write minus infinity to infinity Laplace transform formula xt e to the power minus st into dt. This is my simple Laplace transform formula, guys. This is my simple Laplace transform formula. I hope you agree. But if I want to find the Laplace transform of xt dot e to the power minus at, so I am writing here, if I am changing here minus infinity to infinity, if here I am writing xt dot e to the power minus at and dot e to the power minus st into dt, then this Laplace transform I want to find, then what it will be? It will be minus infinity to infinity x of t dot e to the power. If I will take common in minus, inside the bracket I will get this. So what you will get ultimately, x of s plus a. बोलो चो क्या बोलते हो, हाँ या ना? All of you guys just do reply, बोलो हाँ या ना, x of s plus a. All of you guys just do reply. So that is the only thing we have mentioned here. Why? Because earlier you have written x of s, because of here t multiple, t or minus multiple is s. Similarly here multiple is s plus a, so that is why xs plus a. Similarly, bachcho, if I will take the example, what is the Laplace transform of ut? If I will taking the example also, this is the completed part. If I talk about the example, what is the ut Laplace transform? You must say that up Laplace transform is 1 by s, sir, And what is its ROC beta? ROC is sigma greater than 0. Bolo bhai. Yes or no, whether you do reply beta. So ut Laplace transform is 1 by s sigma greater than 0. Now if I talk about frequency shifting, if I will write the frequency shifting as a e की power minus at into u of t, so don't you think its Laplace transform is nothing but 1 upon s plus a? And earlier if the ROC is r, then now what is the ROC? Sigma is greater than 0 earlier, but in 0 what you are adding now? Now you are adding this value minus a. So you are adding this minus a. That is why sigma is greater than minus a this time. So that is why I have written here ROC real part plus minus a. Whatever the minus a you have to add here. Just like this. Similarly, e to the power plus at u of t, the Laplace transform is nothing but 1 upon s minus a, and this time ROC sigma is greater than plus a. Sigma is greater than plus a. All of you guys just do reply. Shall we go for next? But if I talk about this, कि e की power plus j omega 0 t into ut, is it visible to you, beta? Is it visible, the last expression? Yes. So its Laplace transform is nothing but 1 upon s minus ka j omega 0. Its Laplace transform is nothing but 1 upon s minus ka omega 0. And its ROC is what? Its ROC sigma is still greater than 0. Why? Because real part of j omega 0 is what? Real part of j omega 0 is 0. Real part of j omega 0 is 0. Bolo ha ya na? Important property as far as ROC is concerned, because ROC effect. Important property as far as ROC is concerned, because ROC effect. Shabash. All of you guys just do reply fast. Shall we go for next, pyare bachcho? All of you guys just do reply fast. Shall we go for next? Chalo. NOW beta, NOW. I think this property is crystal clear to you. I think this property is clear to you. Yes, chali. So student, if I talk about just relate to the property, if I talk about what is the Laplace transform of sine omega 0 t into ut. Tell me beta, what is the Laplace transform of this? If I will convert the sine omega 0 t in the exponential form, then I will get e to the power plus j omega 0 t minus e to the power minus ka j omega 0 t upon twice j into ut. If I talk about the first e to the power plus j omega 0 t into ut Laplace transform, then tell me beta, what is Laplace transform? Its Laplace transform is nothing but 1 upon s minus ka j omega 0. And what is the ROC? The ROC is nothing but sigma greater than, bolo ROC kya? Sigma greater than, sigma is nothing but mode. Sigma greater than mode of j omega 0 or real part of j omega 0. Real part of j omega 0. So j omega 0 real part is 0. So ROC is greater than 0. Similarly, if I talk about e to the power minus j omega 0 t into u of t, so it is just we have discussed the last slide, frequency shifting. So s plus j omega 0, ROC is still sigma greater than 0. If you know this result, so can I write, student, here next? Can I write the Laplace transform directly now? Yes, sir. If I will write the Laplace transform directly, 1 upon 2j I am taking the outside, then inside the bracket what I will get? I will get 1 upon s minus ka j omega 0 minus 1 upon s plus j omega 0. All of you guys do reply beta, ha ya na, yes or no. And if you are getting this, then tell me in the next step what you will get. 1 upon 2j is already outside the bracket. So here you will get a plus b, a minus b. So you should write s minus j omega naught or s plus j omega naught. So here you will get actually s plus j omega naught minus s minus plus j omega naught. Bolo ha ya na. Now don't you think bachcho here s and s get cancel out. So ultimately you will get 1 upon 2j outside the bracket, and here you will get actually twice j omega naught upon s a plus b, a minus b. So s square minus j square omega square, j square again minus plus. So omega 0 square and this 2j get cancelled out. So that is why the Laplace transform of this is nothing but omega 0 upon s square plus omega 0 square, and where most important part is ROC sigma is greater than 0. बोलो हाँ या ना? बोलो हाँ या ना बच्चों? Sin omega 0 t ut Laplace transform is clear to you? So that is why sin omega 0 t ut Laplace transform is nothing but actually omega 0 upon s square plus omega 0 square, and ROC is nothing but sigma greater than 0. ROC is nothing but sigma greater than 0. बोलो क्या बोलते हैं? Is this crystal clear बच्चों? Is this crystal clear? Just let me know. All of you guys just let me know, is it clear? Just complete this part, beta. Just complete this part. Just take your time and complete this. So sin omega 0 t ut Laplace transform of this omega 0 upon s square plus omega 0 square, ROC is sigma greater than 0. ROC is most important, yes. Now everybody just do reply fast. All of you guys just let me know. Shall we go for next, प्यारे बच्चों? बोलो बोलो बोलो. Shall we go for next? चलिए. Similarly, student, can I write for the cos also? Because in the cos only the term is here is plus and here is j. So can I write similar form? Can I write similarly? If I want to save my time, then can I write similarly for cos? Similarly, can I write for cos? Yes, sir. So for cos omega 0 t into ut, cos omega 0 t into ut, the Laplace transform is nothing but s upon s square plus omega 0 square, and ROC is nothing but sigma greater than 0. ROC is nothing but sigma greater than 0. Cos omega 0 t ut, the Laplace transform is nothing but s upon s square plus omega square, and the ROC is nothing but sigma greater than 0. Is this clear, bacha? Is it crystal clear, pyare bachcho? Just do reply fast. Sigma greater than 0, yes. Shall we go for next, प्यारे बच्चों? NOW. चलिए. So student, now my question to you all: can you find that Laplace transform of sin omega 0 t u minus t? Can you please find out the Laplace transform of sin omega 0 t u minus t? बोलो. U minus t. So if I talk about here again, e to the power j omega 0 t it is, or we can check for cos also, sin also. So e की power j omega 0 t minus e की power minus का j omega 0 t upon twice j. I am just copying for sin. Similarly cos we can write. So u of minus t I am writing. So if you know that कि sir e की power plus j omega 0 t into u of minus t, Laplace transform is what? U minus t. So u minus t Laplace transform itself 1 upon minus s. And here frequency shifting matlab s will replace as what? S is replaced as a s minus ka j omega naught t. What is the ROC here? ROC sigma less than 0. Similarly, e की power minus का j omega naught into u of minus t. What is the Laplace transform? So its Laplace transform is nothing but 1 upon minus s is already for this, but this time s will replace as a s plus j omega naught, and sigma is already less than 0. If you know this fact, then this fact you can apply here. Laplace transform. So what you will get? You will get 1 upon 2j outside the bracket, 1 upon 2j outside the bracket, and here the first term what you will get? You will get 1 upon, if I will open the bracket now, then I will get actually minus s plus j omega 0. हाँ या ना? And here what I will get? Here I will get minus, both are minus, so I can take minus sign here also. Bolo yes or no, guys? If I will take both minus sign, so okay, if minus is outside only, it is also great. So minus is outside, it means minus 1 upon s minus का j omega naught, and again minus 1 upon s plus j omega naught. This is in the bracket, guys. हाँ या ना? And as far as ROC is concerned, its ROC is nothing but sigma less than 0. So now tell me, what is the final Laplace transform? 1 upon 2j already outside the bracket, sir. Here when you will take the LCM, what you will get this time? This time you will get s minus का j omega naught into s plus j omega naught, again minus के साथ s minus का j omega naught और minus के साथ s plus j omega naught. बोलो हाँ या ना? Minus का s plus. All of you guys do reply. So 1 upon minus का s, here is where you have did mistake here, just let me know, guys. Calculation part, just check the calculation part, beta. Minus, this is minus, this is plus. Yes. So here is s minus j omega naught minus s so because of s equal to minus s and s के अंदर because of minus s and s you have replaced as a minus j omega naught, so actually it is s minus plus j omega naught, or it is also this. Okay, so here I am just writing the again expression because in the LCM you are getting the, actually you get the minus ka 2j na, minus ka 2j. So again I am writing this. So actually what I will get, e की power minus s plus j omega naught. So you will get minus का s plus j omega naught. बोलो हाँ या ना? This is clear बच्चों? This is clear? Minus का s plus j omega naught. This is clear or not clear, sir? And this what you will get? This you will get again plus 1 upon, because u minus t Laplace transform is what? U minus t Laplace transform is 1 upon minus s only. Now, if I will provide the shifting with e की power minus का j omega 0 t, u of minus t, so your s will replace, minus is already outside, your s will replace as a s opposite sign मतलब plus j omega 0 t. So what you can write 1 upon minus का s plus j omega naught, minus का s plus j omega naught, और here you can write minus का 1 upon s plus j omega naught. बोलो हाँ या ना बच्चों? So if I will take common here, 1 upon 2j already outside the bracket, minus already common, so here you will get s plus का और minus का j omega naught, and here is also minus का 1 upon, बोलो. अच्छा बच्चों, here also minus sign ना बच्चों. Here why you are taking plus sign, sir? Here minus sign is there, sir. 1 upon. I hope now you are getting, beta. I hope now you are getting. So minus or minus, one more minus, it will become plus ना. इन दोनों के बीच में भी तो माइनस साइन है यार, इन दोनों के बीच में माइनस साइन है, और ये अपने आप में यहाँ माइनस लेके आ रहा है, एक और माइनस लेके आ रहा है, ये माइनस लेके आ रहा है अपने आप में, s plus j. आई थिंक वेदे यू हैव नोटेड दिस, हाँ है ना? देखो बेटा, इन दोनों के बीच में एक नेगेटिव साइन है, ये नेगेटिव साइन, ये वाला गोला, ये नेगेटिव साइन, और यहाँ पे क्या आया, रिजल्ट लेके आया 1 अपॉन माइनस का s माइनस j ओमेगा नॉट. तो उसको मैंने लिखा, ब्रैकेट ओपन करके लिखा, या वापस इसको ब्रैकेट को बाहर करके लिख दिया, माइनस का s माइनस j ओमेगा नॉट, यहाँ तक ये लिख दिया. और ये पार्ट जो लिखा मैंने, ये पार्ट मेरा क्या है, माइनस कॉमन है और ऑलरेडी एक माइनस बाहर है, तो माइनस माइनस प्लस नहीं हो गया, ये फिर प्लस हो गया सर, प्लस हो गया. तो अब आप लिख सकते हो यहाँ s प्लस j ओमेगा नॉट. ये लास्ट टाइम हमने ये माइनस वाला साइन मिस कर दिया था. नाउ बच्चों तो बताओ जरा, क्योंकि हमने ये मिस कर दिया क्योंकि ये बीच में माइनस था, हम मान के चल रहे हैं कि प्लस नहीं होगा. अगर प्लस होगा तो फिर तो कॉस हो जाएगा ना, कॉस हो जाएगा फिर तो. चलो, सो 1 upon 2j, when you will take LCM here now, you will definitely get a square plus b square मतलब s square plus omega 0 square, and you will get here minus का s minus का j omega naught and plus s minus का j omega naught. So now this time s's get cancel out. So what ultimately you will get? You will ultimately get minus का twice j omega naught upon s square plus omega square and upon 2j outside bracket था. So don't you think 2j कट गया? So the final result is nothing but minus omega naught upon s square plus omega 0 square. ये, this is my final result, guys. This is my final result, and what is the ROC? This is my final result, and what is the ROC? Come on. What is the ROC beta? What is the ROC? Minus omega naught. So ROC is nothing but less than 0, sigma less than 0. Minus omega naught upon s square plus omega 0 square, and ROC is nothing but sigma less than 0. Similarly, just do it fast. After that, similarly we can write for cos also. Very good beta. वैसे ही minus का आसान आएगा आगे. Minus omega naught upon s square plus omega naught square, and ROC will be sigma less than 0. बोलो आया ना बेटा? ROC will be sigma less than 0 beta. Is it clear or not? Is this clear or not beta? Every student just do reply fast. Shall we go for next? Every student just do reply fast. Shall we go for next? Chalo. So I think this part completed already. Yes. Chali. So conclusion is what, guys? Sine of omega 0 t into u of minus t, its Laplace transform is nothing but 1 upon, bolo 1 upon minus ka omega naught upon s square plus omega naught square, ROC is less than 0. Similarly, can I write cos for cos also? You can write for cos also. Cos of omega 0 t into u of minus t, the Laplace transform similarly is nothing but what, guys? Minus ka s upon s square. So as far as formula is concerned, you can remember easily because of u minus t, minus sign in the Laplace transform, and because of this sigma ROC is less than 0. This is how you guys can relate. Yes. This is how you guys can relate. Yes. But student, in signal sense system, I am again talking about, if I will ask the Laplace transform of sine omega 0 t in control system, if I will ask the Laplace transform of sine omega 0 t in control system, then of course you will reply omega 0 upon s square plus omega 0 square. Because in control system, it is by default we are talking about t is greater than equal to 0. In control system, we are talk about by default t is greater than equal to 0. What I am saying? T is greater than 0. I hope you are getting this. Guys. Hi, Anna. I think there is some problem in the camera setting. Let me change the. चलिए बच्चों, I think this is clear now. I think now board is perfectly visible. चलिए, so this is all about. Now if I talk about the next बच्चों, कि sin omega 0 t u minus t Laplace ROC is this. If anybody will ask about in signal sense system, कि what is the Laplace transform of sin omega 0 t, then tell me what is the answer. Then tell me what is the answer, beta Vedai. Tell me what is the answer. Sin omega 0 t ut, what is the answer this? What is the Laplace transform now? Come on. So for sin omega 0 t, now you can say that कि because sin omega 0 t is either it should multiple of ut or should multiple of u minus t. If this is multiple of 1, it means again no common ROC. Again you can say that no common ROC, so no Laplace transform. Because in the, as far as signal sense system concerned, it should be multiple with either ut or u minus t. But in control system, if I am asking, in control system subject, if you are taking a transfer function question, and if anybody will ask about the Laplace transform of sin omega 0 t, or even in the maths also, then you will directly reply omega 0 upon s square plus omega 0 square, because that time by default it is for t equal to 0 plus only, because by default it is for t equal to 0 plus only. So in terms of signals and system, actually sin omega 0 t is equivalent to sin omega 0 t ut. हाँ या ना? But in signals and system we have to be specific कि whether it is sin omega 0 t ut or sin omega 0 t u minus t. If it is given that find out the unilateral Laplace transform of sin omega 0 t, which is having the limit 0 to infinity, then of course omega 0 upon s square plus omega 0 square. हाँ या ना? So you have to check what is the mentioned term. Okay, प्यारे बच्चों? Yes. So that's all from today's class, guys. We will meet on tomorrow, and very soon I am going to announce for the August month initiative also for you. Okay, so you should tell me when we will take this session by tomorrow. Okay, so I will plan this YouTube initiative session by tomorrow only. Okay, I will make the upcoming live event also very soon. Okay, प्यारे बच्चों, चलिए. So that's all from today's session, guys. That's all from today's session. Okay. चलिए. So बच्चों, if you are looking for a good practice question, है ना, so just come for the announcement. In the announcement session, you all should be live and share that announcement session with maximum, so that it will be benefited to maximum students. Okay. चलिए. Those who are looking for the complete structure gate preparation from IMS GATE Academy, you guys can visit our IMS website, that is ims.com/gate, and you can also once you will enroll. Sir, Monday का मेरा बैच का रिजल्ट आया है, मेरा बीटेक का रिजल्ट आया था सर, क्या बात है. many congratulations वैदेही, 8.35 CGPA, many congratulations बेटा, many congratulations, शाबाश, आपका इतना अच्छा बीटेक का रिजल्ट है. अब इसी को मेंटेन रखना है आपको गेट में भी आपको 80 मार्क्स लेके आने हैं. if I able to cover 75 plus marks, then also it's a big achievement. उसमें कुछ सब्जेक्ट आप ही से पढ़े थे मैंने. Okay, welcome बेटा, thank you for sharing your experience. वैदेही, thank you for sharing your experience बेटा. एंड पूरी ताकत के साथ अपने एक्सपीरियंस को सबको बताओ, अपने जूनियर्स को बताओ कि कौन है अंकुर सर, क्या पढ़ाते हैं, कैसा पढ़ाते हैं, कहाँ पे पढ़ाते हैं, है ना. हर एक चीज़ पूरी ताकत के साथ इन्फॉर्मेशन सबको पहुँचाओ. इफ़ यू एक्चुअली गेट बेनिफिटेड, देन जस्ट शेयर योर इन्फॉर्मेशन एज मैक्स एज पॉसिबल. ओके, यू आर मोस्ट वेलकम बेटा, मोस्ट वेलकम वेदर, मोस्ट वेलकम. हर एक सिंसियर स्टूडेंट का जो पढ़ा है, पढ़ना चाहता है, उसका हमेशा स्वागत है. चलिए. So बच्चों, once you will join the IMS GATE Academy, you will get 800 plus live lecture access, you will get 350 plus recorded video access, you will get 26 to 30 hard copy of booklet that will cover theory book, exercise book. Exercise book contain 4,000 plus practice questions. After that, you will get 130 plus test series also. You will get subject test, advanced subject test, multiple subject test. So student, once you will enroll, then only these features you will get the dedicated doubt solving portal also. Okay. So चलिए, that's all from today's session. We'll meet tomorrow morning. Tomorrow morning we are making the session from now onwards 12:15, because in the Bangalore actually we have a heavy traffic. And evening I have a paid online live class on the on our enrolled students. For the enrolled students I am having classes. So that is why late night also I reach home at 10. Okay, so that is why what we are thinking कि we are making the session at 12:15. Okay, 12:15. चलिए, 12:15 to 1:15. Okay, from tomorrow onwards. चलिए. Okay बच्चों, bye bye, take care. That's all from today's session, and I will make sure that all the session that is not yet uploaded or updated in the playlist, it will be updated very soon. It will be updated very soon, by today only. Okay beta, bye bye, take care. That's all from today's class, Vedai. And all the students will meet tomorrow. Okay.